Hi guys, have you ever played this game, The Running Dino? Usually you wouldn't have to navigate to a website and then play it. All you have to do is turn your internet off and you will be greeted by this T-Rex. And the one thing that is more frustrating than the internet outage itself is that we suck at playing this game. No matter how much you try, you will hit, you will stumble and you will die at one point. And the frustration you get on dying after a long run, that thing cannot be put into words. So I did what I can to automate this dino to play its damn game by itself.
Don't try to understand it, just feel it.
The first step of automation is that you'll have to download a local copy of this JS file and then add all your modifications to that. Let me do it right away. So this is the file, and whatever changes made here in this file will be reflected in this panel and your Dino will behave according to that. After digging through this for hours and trying to understand every single functionality it has and every single property it holds, I've got to know that there are a few properties or objects that we need to remember. Runner, which is the Dino. Horizon. This is the environment. And this contains obstacles that you encounter. Cactuses, pterodactyls, the flying dinos, and more. As of now, these two are the most important ones that we need to automate the dino. So let's look into that. Since we are not going to add any new functions, we should just try to leverage an existing function and add our code into it. It's like we are injecting extra code into an existing function so that when that function is called, our code will run along with the existing code. So we'll have to choose a function that gets called very frequently so that our code that we inject into that function also will be run every single time the function is called. But what are we even trying to achieve with that? Let's look at the game first. So what does this game contain? There is a dinosaur that's running, and whenever there's an obstacle, it should either jump or it should duck, depending on the type of obstacle. If it is a ground-borne obstacle like a cactus, it can jump, or if it is a flying obstacle like a pterodactyl, it should duck. But not always, because some pterodactyls fly at a higher altitude and some fly at a very lower altitude. So depending upon that as well, we should decide whether the dinosaur should jump or duck. So to decide that, we should first be able to recognize when an obstacle is coming nearer to our dino. So the obstacles are marching from right end of the screen to the left end of the screens, and the dino is at a fixed position. So what I'm assuming is that, after going through the code, I've concluded is that this is a Cartesian coordinate map, and there are some coordinates for this dino and there are some coordinates for all the obstacles that are arriving towards the dino. So whenever they come closer, we will choose a safe distance. So whenever they come beyond that safe distance or when they get closer than that safe distance, we'll trigger the dinosaur to jump, or we'll ask we'll code it in such a way, we'll program it in such a way that we'll find out the height or we'll find out the XY coordinates of the obstacle and then make the dinosaur a relevant action like jumping or ducking. To put it briefly, this is what we're trying to program into the code. So for doing this, we should be able to check whether the obstacle is nearer almost every moment. So we should choose a function that will be called very frequently. And after going through the code, I've concluded. After going through the code, update function inside the runner.prototype is the best function because it gets called every now and then. Even to determine whether the game is over or whether you have hit the obstacle, this function is called. So what better function there is to inject our code into than this? Let me create some space over here to write our own code. Our custom code. So this is where we're going to add our custom code. And if you look at line 384, it has already defined a variable called has obstacles. That variable determines whether there is any visible obstacle in the viewable screen. So we are going to use that. If there are any obstacles on the screen, we should do something, and we'll define what that something here is. I'm taking a variable. This is going to be a boolean type variable, and this decides whether the dino should jump or not. This function isn't defined yet, we'll define it later. If it is ready for jumping, let's just say, what should you do? So now we are checking for the obstacles Y position, which is the vertical position in the map. And its height. So we are just trying to check whether we have space over the obstacle so that we could jump, or under the obstacle so that we could duck. This is what we are trying to achieve through this piece of code. If it is less than our TLX's Y position, this is just a debugging statement. And then you should duck down. Well, we haven't defined this function as well. We'll do it in a while. Or else it should jump. Yes, so this code is ready. So what happens is whenever the engine calls this update function, in addition to all the functionality that gets executed, which is necessary for the functioning of the game, our own custom code will also be executed, which helps us to determine whether the dinosaur is ready to jump yet or not. So how will you determine whether the dinosaur is ready to jump or not? That logic is going to go inside this function. Let's write it down somewhere here. Function, and it's called ready to jump. Cool. I'll talk about this line later on. Let's move on with the coding. I'm going to establish a safe distance, which is 35. It's not anything logical or scientific here. I've just taken a random number. So in these two lines of code, I haven't done anything special actually. I'm just replacing such huge commands with one single variable. So whenever I'm going to reference these huge commands in the future or in the upcoming lines of code, I just have to I just have to use these variables instead. That's it, nothing fancy here. So this is the dimensions of our T-Rex or the dinosaur. Even though it looks like a regular dinosaur with tiny hands and long legs, etc., as per computer it has a few dimensions and it is just a rectangle. So it has an X coordinate and it has a Y coordinate that we call the origin of that particular dinosaur box, and it will have a height and it will have a width as well. So when you combine that, you will get a rectangle. So that's how the computer actually detects whether the dinosaur hit a particular obstacle or not. There is no dodging the bullets like Neo does in Matrix. It's a box and the obstacle is also a box. If these two come in contact with each other, the game is over. That's it. So let me define the boxes of obstacle as well. So now we are done creating the boundaries for the dinosaur and the obstacles. The next step in the process is to determine whether they collide or not. Let's just say okay, here I am just checking if there are more than one obstacles in the screen right now, because depending on that we should determine whether the safe distance should be more or less. Didn't understand? Let me explain. Let's just say there is the first obstacle and the second obstacle which are at quite a lot distance. So you can jump over the first obstacle, run towards the second one and jump over. Cool, it works fine. But let's just say the first obstacle and the second obstacle are so close to each other that if you jump over the first obstacle, you will fall upon the second one. So what you should do is you should jump at a farther distance from the first obstacle so that you will just land just beyond the first one and you can jump again to go over the second obstacle. It's like I'm speaking in Hebrew right now, but you'll say it in action. So the logic, the mathematical logic comes here. If the obstacle 2 box, which is the boundary of the second obstacle, minus the first obstacle x coordinate plus the first obstacle's width. What we are trying to do is the leftmost coordinate of the second obstacle and the rightmost coordinate of the first obstacle. We are trying to check the distance between them. That's it. If this is equals less than or equals to 50 into the T-Rex's current speed, and there is this parameter called current speed which usually starts at 6 and it will increase gradually. It's like the dinosaur is accelerating. The safe distance should be less. It should be very lesser than the initial amount, which was 35, and now it's reduced to 20. Else if the leftmost coordinate of the second obstacle minus the rightmost coordinate of the first obstacle, which is if this is greater than 50 is just a random number, don't worry about it, is greater than runner dot its current speed. Safe distance should be significantly more, which is somewhere around 100 or 125 or something like that. Okay, back off. What did I just do here? You may be worrying about looking at long words or very long references here, but the thing is very simple. With this initial condition, I'm just verifying that the T-Rex is towards the left of the obstacle, which means I'm just verifying that the obstacle is coming towards the dinosaur and not going away from the dinosaur from behind it. This is the first condition. And the second condition here is verifying that the leftmost coordinate of the obstacle and the rightmost coordinate of the dinosaur are less than safe distance or not. Let's just say the safe distance is 125 and the dinosaur and obstacle are just 100 pixels apart. So it will return true, which means the dinosaur is ready to jump. But let's just say the safe distance is 125 and the dinosaur and the obstacle are 200 pixels apart. Then it will return false. It will instruct the dinosaur not to jump because it's too early. That's what this function does, nothing fancy. You can go through the code, I'll put it up in the description. You can put it out in comments or reach out to me directly. I'll put my email in the description as well, email and my social media handles. You can text me then. So we have defined one big function actually. And if you remember well, we are yet to define two more functions, duck down and jump up. So let me just write that. Duck down. We'll just instruct the dino to duck. Simple. Yes, that's it. That's the whole function. Nothing like the previous functions that we have written. Jump up. We'll instruct the T-Rex to jump. Jump. We're starting one more to it, just in case. So now we are done with the functions. We have defined all the functions that we want and this is the time for execution. Let's save this. Reload the page so that all the changes will be loaded into here. Yep. As you can see, all the code that we have had is reflected here. Our custom code, and so we just run the game and see if it can actually achieve the functionality that we wanted it to achieve. Okay, there's a problem because the dinosaur went invisible. Let me go back to the code. Okay, I think the problem is gone now. Let me reload it. Wow. The game again. Cool, it is jumping. I'm not pressing anything. Trust me when I say this. Right, voila, the functionality is achieved. This is it, but the tuning has to be done by yourself because I have just entered random numbers. As you have seen, the safe distance is 35, 25, 125. These are just random numbers. They are not logically accurate or mathematically accurate. So there are higher chances that it may stumble upon in the future like this. So tune your game, and as the dinosaur's speed increases gradually, the safe distance should change in proportion to the increasing speed. So you can maybe derive a mathematical formula for that to map the changes between these two. But basically, as per programming, this is how you do it. Now you don't have to worry about whether you are good at playing this game or not. You're welcome. Because now you have to actually worry about tuning the code properly. And all the best for that. Adios.